Number one, the absolute value is already by itself. We've isolated it. It's less than or equal to 13, so we rewrite it as an in-between compound inequality because it's less than. That's our rule. So we write 5x plus 2 will be less than or equal to 13 or greater than or equal to negative 13. So when it's less than or equal to, we write it as an in-between. Everybody okay with that? Yeah. That should be in your notes. Okay, so whatever we do to the inside, we have to do to the outside in order to isolate x. So I'm going to subtract 2. I get a negative 15, and I get 5x in the middle, and I get 11, right? Right. So now I'm going to divide everything by 5 because I need to get 5 by itself, or x by itself. And I have a negative 3, and then I have my x, and then I have 11 over 5. That is 2.2. Exactly. Right? Okay. So the graph of this is going to be everything between negative 3 and 2.2 inclusive, which means filled in circle, everything in between. Interval notation, bracket, negative 3, comma, 2.2, bracket. Good? Everybody all right with number 1? Okay, so let's move on to number 2. I'll stop this and you can catch up. And first step, we want to add 5 to both sides. Then we have a negative 5 times the absolute value of x minus 3 is less than 20. And I need to get rid of that negative 5 out front. So that means I'm going to divide by a negative 5. And because I divided by a negative 5, I'm going to change the direction of my inequality to be greater than now. And that is negative 4. So we have the absolute value of x minus 3 is greater than negative 4. So in the past, when we worked with an equal equation and we had it equal to a negative 4, we knew that was no solution because there's no way any absolute value will equal a negative number. But with an inequality, we can have absolute values that will be greater than a negative number, correct? All of them will be greater than a negative number. So we can still work this out using the same rules that we did with the other greater thans. So remember, when it is greater than, we write two inequalities using or. What happened to my stuff here? I don't know what happened there. What happened? Where'd it go? Everything's a little spooky today. All right, we're going x minus 3 is greater than a negative 4, or x minus 3 is less than a positive 4. Same rule applies. We write it as it is, and then we change the direction and change the sign. So, or means we write two inequalities, write the inequality as it is. X minus 3 is greater than negative 4, or x minus 3, change the direction, change the sign. Add 3 to both sides here to get x by itself, so I will have x is greater than a negative 1, or add 3 to both sides, I get x is, plus 3, and I get x is less than 7.
Good. Wouldn't that be
right?
X is in between negative 1 and 7?
Okay, so let's look at this. I'm going to graph it because sometimes I need a visual. So here's my negative 1. There's my 7. So the solution says that x can be greater than a negative 1, or x is less than 7. Okay, or means the union. We just put them together, right? Put both of them together. They don't have to have anything in common. They can. What is the simplest graph that shows all of that? Those solutions put together. What is the graph that's going to show those two solutions put together? What's our farthest left point that'll be on the graph?
Negative 1.
Well, what about this right here? That's part of the solution, correct? What's the farthest right point of our solutions? Positive infinity. So your answer is the whole number line. Any number on the number line could be a solution to this inequality. Or means one or the other. So they don't have to overlap. And is where they would have to overlap. In which case, if this was an and problem or an in-between, you know, like we set up the last problem, they overlap here to here, correct? That would be our solution set. This is not an and, this is or. So it could be from one solution set or the other solution set. But what's the one solution set that covers both of those? All real numbers. So to state our answer in interval notation, negative infinity to positive infinity. Everything works in this inequality.
Every absolute value will be greater than a negative.
Because every absolute value would be something greater than a negative 4. Every value for x would give us something. So, what's your question? No, because that wouldn't work. We would want to use that when they're going opposite directions and they don't intersect. That's when we'll want to use the u. Opposite directions don't intersect, we would use the u. If they go towards each other and intersect and then go away, then that's the whole number line. That's everything. We haven't had one like that yet, have we? Okay. Nor have we had one like the next one. So, are we ready to move on to the next one? So, to isolate the absolute value, first step, subtract 10 from both sides. I have 8 times the absolute value of x plus 4 is less than negative 8. Divide by 8. I get the absolute value of x plus 4 is less than a negative 1. So you can read this and you can say, will I ever have an absolute value that is less than negative 1, smaller than a negative 1? No, because we can never have an absolute value that is negative. But what if you can't see that? That doesn't connect for me. So I'm going to rewrite this as an in-between because it's a less than. So I would write it as x plus 4 is less than negative 1, greater than 1, correct? Okay, so then to subtract, to get x by itself, I'd subtract 4. I get a negative 3 here, I get x in the middle, and I get a negative 5. So graphing. So if I just read the left, x is greater than negative 3, correct? I'm only reading the left part to graph. This part tells me that part of my solution is x is greater than negative 3. So that's open circle to the right. The other part is saying that x is less than a negative 5. So to graph that, I would go open circle to the left. Now, when it's less than, it has to be what they have in common. Do these graphs have any solution in common?
No.
They do not overlap. So our answer is no solution or empty set. And that only happens when it's a less than. If we graph our solution to our less than and they do not intersect, then there's no solution. Another way to see this is that how do we usually have this? We usually want the smaller number on the left. And if that's not the case, if it doesn't end up that way, then you should red flag that there's something not right with this. Maybe I ought to graph this and then see that it's no solution. Okay, all right. So we're ready for Fun Friday.